Math Prep for High School Science. Introduction to Solving Equations. High school science introduces a lot of amazing concepts. However, even if you love the material, a lack of math skills will keep you from rocking those courses. This video is part of a series to introduce you to the math concepts you will need to succeed in high school science. We look at how to rearrange equations to solve for the unknown variable. Two quick caveats. First, I'm ignoring significant figures. You will learn this concept as a science student. You don't need to practice it ahead of time. Second, I'm not using unit labels. Instead of 50 miles per hour for 2 hours equals 100 miles, I'm just saying 50 times 2 equals 100. Unit labels are really important, and you'll be doing yourself a huge favor to work on the habit of using them in science. But for this video, we just want to see how the numbers work. Consider this messy equation full of gobbledygook. We want to solve for x, but it's buried in the middle of all this junk. The purpose of learning how to rearrange equations is that we can transform this into this. If we can get x, or whatever the variable is called, by itself on one side of the equation, then we can determine its value. We're starting with two keys to rearranging equations. First, what you do to one side of an equation, you must also do to the other side. An equation has two sides, which are balanced to be equal. To keep the sides balanced, you must treat them the same. Second, we'll use inverse operations. That's just a fancy phrase for opposites. We'll use opposite operations that can undo each other. These are two of the most useful pairs in science. First, addition undoes subtraction, and subtraction undoes addition. Second, multiplication and division are each other's opposites, so they undo each other. Let's practice these skills. For each problem, the top blue area will include the information given to us in our word problem, the variable whose value we want to solve for, or find, and the relevant equation. We'll start with an equation for converting between temperatures measured in kelvins and degrees Celsius. The problem tells you that K equals 290. It asks you to find degrees Celsius. And the relevant equation is K equals degrees Celsius plus 273.15. First, I'll copy down my equation. Now I'll plug in any values I know. I know K equals 290. Take a minute to make sure you're on track. You want to solve for degrees Celsius, and that's the only variable left in your equation. That's a good sign. Now it's time to rearrange the equation to solve for our unknown, degrees Celsius. Look to see what's hanging out on the same side of the equation as degrees Celsius. The only term in this example is plus 273.15. Remember that subtraction is the opposite of addition, so we'll subtract 273.15 to get it off the right-hand side of the equation. But whatever you do to one side of the equation, you have to do to the other side of the equation. So we'll subtract 273.15 from both sides. The 273.15s on the right side of the equation cancel out. On the left side, we get 290 minus 273.15, which is 16.85. So 16.85 equals degrees Celsius. It might look weird to you because in algebra we always put the variable first. X equals 3, y equals 120, etc. So if you want to have it in the form where the variable comes first, feel free to just swap the sides. After all, if a scale is balanced, it'll still be balanced even if you spin it around. Before we explore other equations, let's move our original work over to the side so I can show you an alternative approach to rearranging equations. Instead of plugging in known values and then rearranging to solve for the unknown, you also have the option of rearranging to solve for the unknown and then plugging in known values. To do this, we try to get our target variable isolated, that means by itself on one side of the equation, before we plug in any values. So what else is hanging out on the right-hand side of the equation with degrees Celsius? Just plus 273.15. Since 273.15 is being added, we undo it with subtraction. And what we do to one side of the equation, we do to the other. Now degrees Celsius is by itself. You're free to swap the right and left sides if you like your variable on the left, but that's totally optional. Now plug in your known value. K equals 290. Do the arithmetic. All you have is subtraction, and your answer is degrees Celsius equals 16.85, the same as before. So which way should you use? It's up to you. I recommend trying both and noticing which method leads to fewer careless errors. For the rest of the video, I'm going to plug first and then rearrange. Either method is a good option. Choose what's best for you. Our next equation deals with delta T, which is T sub F, final temperature, minus T sub I, initial temperature. First, we plug in the known values. Delta T equals 15 and T sub I equals 8. We want to solve for T sub F, which is the only variable left. So now it's time to rearrange the equation so we can isolate T sub F and solve for it. The only operation occurring on the same side of the equation as T sub F is subtraction, which we can undo with addition. What we do to one side of the equation, we also do to the other side. So we add 8 to both sides. We get 23 equals T sub F, or T sub F equals 23. Let's try an equation with multiplication. This is from physics. Force equals mass times acceleration. Makes for some great Star Wars puns. In this example, we're given F and A, and we want to find M. We plug in the values and see that M is in fact the only variable we don't know. That means it's time to rearrange so we can solve for M. The right-hand side of the equation is M times 10. The only operation is multiplication. We isolate M by dividing by 10. This undoes the multiplication. Of course, we don't divide just one side. We divide both sides by 10. Our final answer is 3.2. You also have the option when you divide by 10 of writing it as a fraction. Now we'll do a division problem. Rho, that's the curvy-looking P-like letter, equals M divided by V. Plug in our known values. Rho equals 20 and V equals 15. 20 equals M over 15. We want to determine M, and it's the only variable left in our equation. Time to rearrange to solve for the unknown variable M. We can undo divided by 15 by multiplying by 15. What we do to one side of the equation, we do to the other. M equals 300. So remember, whatever we do to one side of the equation, we have to do to the other side. That's what keeps it balanced. We rearrange by using inverse operations, or opposites. We learned the two most basic pairs of opposites. Addition and subtraction undo each other, and multiplication and division undo each other. With these keys, you're ready to rearrange and solve the most basic equations. Good luck!